My name is Kelly Pavel. I'm with the Steam System Technical Support Team, and today I want to talk about Swagelok steam trap stations. With steam trap stations today, we look at old technology, which is threaded connections using a number of components to put the assembly together. Today, one assembly. Have my blocking valves, connector, strainer, and I'll talk about these benefits and features. One of the things we're doing with steam trap stations is installation consideration. How much is going to cost me to install the steam trap? If I have 14 threaded connections, and 14 threaded connections show here. So I have one connection here, one, two, three, four, five, six, seven, 8, 9, 10, 11, 12, 13, 14, 14 threaded connections. And the thing is we have to look at the cost to put these threaded connections in. Let's say 15 minutes per threaded connections, or 3.5 hours. And our labor rate's $80 per hour. This here would be $280 just in labor costs, not including the material cost for putting all this together. Now, the thing is that the ideal situation over threaded, one of those is welded. And the welded cost would be 2 to 3 times this. So we could easily be over $1,000 just putting the steam trap station together. One of the things when we use threaded connections is there's 14 leak points that possibly going to occur in the system. And doing root cause analysis with steam leakage throughout the world, number one cause of steam leakage is threaded connections. So we want to do whatever we can to eliminate the threaded connections in the system. And that comes to the Swagelok steam trap station. Advantage, we have 2 connecting points. We have a point here and point here. And we use tube connectors, which, as everyone knows, tube connectors are guaranteed not to leak. These installation cost now comes down to about 30 minutes or $40, even less, depending on the person that's putting on the we're installing the steam trap station. The thing with this here, the steam trap connects right there with 2 bolts. So you can easily put the steam trap on the steam trap station 5 minutes or less. The thing is that one of the biggest advantages with this system is we never have to break pipe to remove the steam trap. Steam traps are mounted to the universal connector by 2 bolts. The bolts, so the steam trap comes on to this location right here, and 2 bolts connect the steam trap right onto the connector. Boom. And there's a reliable gasket used by the steam trap manufacturer. So we have a positive seal. In my career looking at these steam trap stations, I've never seen one leak at the steam trap station connection. Big advantage. The other thing is, why use the universal connector? All steam trap manufacturers have a steam trap that will mount to this connector. Therefore, you can change out, let's say, an inverted bucket to a floating thermostatic in 5 minutes. You can change out one manufacturer to another manufacturer in 5 minutes. With a common old technology installation, we have to break pipe. So we go down here to these union connectors, and we have to break that open. And when you split that apart, we have to have carefully do this so we don't scrape the surfaces of the bevel and cause a leak point. It typically takes about 2 to 2.5 hours to change out a standard steam trap with threaded connections. And again, with the Swagelok universal connector, 5 minutes. How do they work? So here's a steam line. In the steam line, is that we have condensate that's going to form in the steam line. So the condensate will come down, pass through the strainer here, and through this connection point into the steam trap. And the steam trap is your isolation. It separates the steam and the condensate. And it only allows the condensate to go pass through. So the condensate then is discharged and back out to the system. And that discharge can be on-off operation, or it can be continuous flow depending on the typical design of the steam trap being inverted bucket or floating thermostatic or thermostatic design. Now, safety. One of the biggest things is always safety concern. The thing is that the nice feature with this here is these are lockout tagout handles. So easily I can put on a lock and lock it out. I don't need to encompass it with a valve covering and then lock it out from there. The other thing is using round handles. It prevents people from accidentally opening up the valve. The other thing what I like about is checking for depressurization of the chamber. So when I walk up to the steam trap and the steam trap is connected here, I can open up this valve assembly and depressurize that chamber. So I'm now opening up those two bolts that take the steam trap off, and there's pressure in there, and it's going to blow steam and condensate out into the area, and that becomes a safety concern. And then there's a test valve here, which also allows me to depressurize the chamber and check. So the day of having two valves, and I believe it's kind of eliminated because we can check for depressurization with two different valves and ensure that the person that's taking the steam trap off is not going to get burnt or anything like that, which is perfect. Now, the thing about testing steam traps, one of the biggest things about testing steam traps, visual is very, very powerful. Probably one of the easiest things I talk about is testing steam traps visually. So here I have a steam trap station, and we'll activate this video and watch this handle up here. So open that handle up, and you can see the steam trap is discharging, shuts off. It's an on-off steam trap. It's a thermodynamic design. This is a perfect operation. This is exactly what we want to see. Watch a little bit more, and the steam trap will cycle again. So the person can come up and open up the test valve, and boom, they know that the steam trap is working. The way we can do that, and then we reduce steam trap failures, and we reduce energy consumption, we reduce makeup water costs, and we reduce emissions because we don't have steam traps failed. Now, to determine if a steam trap is in the failure mode, we open a handle and we get a continuous discharge. This happens to be a thermostatic design steam trap, which should be on-off operation, just like we saw on the other video. So with a little bit of training, any person in the plant can check steam trap performance. It's very fast. You just open up the valve and look at the discharge. Thus, a proactive steam trap station management program can be easily implemented. Solutions for steam trap stations. This here is all stainless steel. Magnificent. You know the thing with stainless steel, we're not going to have premature failures. The isolation valves are Class 6 shutoff per FCI standards. That's a positive shutoff. No need for put a wrench onto the valve and torque it down, or what they call a cheater, get a cheater on and get the valves to shut off because they leak. These are the tightest shutoff. Class 6 shutoff per FCI standard meets the API standard. So when you go and shut the valve off, the valve does shut off. The other thing I like about it, it's a very compact footprint. Yeah, as you can see, there's not much distance between the two connecting points, which really doesn't take up a lot of landscape. So another big advantage. The other thing is this built-in strainer. Every steam trap has to have a strainer. Number one cause of failure in steam traps, corrosion material getting into the steam trap. Therefore, every steam trap has to have a strainer head of it, 20 mesh. And depending on root cause analysis, it might have to be changed to 40 mesh. But this assembly here gives you a built-in strainer, 20 mesh. And the strainer is located right here. Now, the other thing is that we have a valve here on the strainer, which is critical because, you know, 2 times a year we want to blow the strainer out and get that corrosion material to come out of there. And before I talked about depressurization of the chamber to make sure that there's no pressure on the steam trap when we take the steam trap off. The other thing is ability to drain condensate at startup. Startup, there's no differential pressure for the steam trap to remove the condensate. So we have to have a valve to open up. This makes an excellent way of draining condensate and venting air at startup, which is exactly what we want to do. The other thing is the bolts are flush. So right here, these connections here, they're flush. And that's a very critical point because it's so easy to get a wrench onto the bolts to remove the steam trap. A lot of other people that make a connection, a universal connector, recess the bolts. And it's very difficult to get a wrench inside there and get the steam trap to be removed. And then here, this assembly, we have a test valve, and the total unit has a lifetime warranty, far exceeding anybody else's warranty in the industrial world. Now, the other thing is that we can also do is come up with different combinations using all technologies. And people say, how should I use, or what technology should I use for connecting steam trap stations or making up steam trap stations? And I tell them flanges, welded, and tube connectors. So here you see assembly, we do it with flanges. So we have a length here of 22 inches, which is a standard length. So every steam trap station in the plant meets this 22 inches. So it's so easy that we have all these made up and we can easily implement them anywhere in the plant. Here's a steam trap station on a drip pocket. As I said before, it's very compact, very compact. So that gives us a lot of cost benefits. Now, these happen to be several of our endless custom solutions for our customers. So every distributor has a custom solution area or shop or team at the locations. Therefore, they can come up with a multitude of different combinations for steam trap stations. And you can see this happens to be a few of many things that we can do with the steam trap stations. So it can provide you a complete package, not just providing you with a steam trap, we're providing you with a solution, complete solution. Thing is that conclusion, yeah, we talked about safety with the Swagelok steam trap station. We talked about environmental energy savings. We talked about installation savings, which is critical, and operational savings by if a steam trap fails, 5 minutes to replace that steam trap. We talked about high reliability, and we talked about steam trap maintenance. So my question is, how do we get started on Monday? Where do we go? How do we get this implemented? Thank you for your time, and have a great day.